Hello everyone, let's have a look at this next exam question on sequences and series. Okay, so it says, show that the summation from r equals 1 to 16 of that expression is 131,798. So let's write that down first. We're working out the summation from r equals 1 to 16 of 3 add 5r plus 2 to the r, and we've got to show ultimately that it equals 131,798. Okay, so what I like to do with this one is break it up into three sums. So we can think of this as r equals 1 to 16 of 3, add the summation from r equals 1 to 16 of 5r, add the summation from r equals 1 to 16 of 2 to the r. Okay, and then further to that, you can actually take a constant outside a summation. So you can think of this as 5 times r equals 1 to 16 of r, like that. So let's break these down and work out what these three separate bits are. We're dealing with each bit separately. So the first term, I've got to work out the summation from r equals 1 to 16 of 3. Now, what does that mean? That just means I've got 3, add 3, add 3, 16 times. So that is 3 times 16. So that is going to be 48, that first term. Okay. Now the next one, we've got 5 times the summation from 1 to 16 of r. So for the sum r, that's where we use the formula n times by n plus 1 over 2. That's something that you need to remember as the formula for sigma r. Sigma r is n times n plus 1 over 2. And in this case, our n is 16. So that is going to be 16 times 17 over 2 times by 5. And then when we work that out, that turns out to come to 680. So we've dealt with the first two terms. The next term, 2 to the power r, is going to be a geometric series. The first term is going to be when r is 1, that would be 2. So our a is 2. And our common ratio is going to be 2 as well, because we're multiplying by 2 each time. So we're going to use the formula n is equal to a times by r to the n minus 1 over r minus 1. And we're using this with the summation formula for geometric series, there's two different versions. You can see it that way, or you can see it with these two terms swapped around. And we use it with this version just because the 2 take away 1 means that we don't have to deal with the negative. They're both equivalent and they both will get the right answer, okay? So it doesn't matter really whether you use that version or whether you use this version, which I'm now writing. They're both equivalent to each other and both are acceptable. It's just convention to use the one that avoids you having to deal with a negative. And because our r is 2, r2 take away 1 is going to be positive. So that's the only reason why we would use that one. So we sub into this and we now have 2 times by r, which is 2 to the power of 16 minus 1, all over 2 minus 1. And when we work that out, that turns out to be 131,000, which is looking encouraging, isn't it? And 70. So now finally, we add these three terms together. 48, add 680, add 131,070, and reassuringly, it comes to 131,798. So that is our first part of that question done, okay? Right, let's have a look and see what's next. So what's going on with this question? Oh, that was 4 marks for the first part done. Okay, so that's our 4 marks. The next part, part 2. Now, part 2, it says a different type of question now. We've got a sequence going on. It says the sequence u1, u2, u3 is defined by un add 1 is equal to 1 over un, where u1 is equal to 2/3. So this time we've got like a recursive kind of like iterative formula. Again, let's generate the first few terms and see what's happening here. So our first term, we're given the first term u1 is 2/3. The second term u2 is the reciprocal of the previous term, so it's going to be 3 over 2. The next term is going to be the reciprocal of the previous term, so it's going back to 2/3. So we've not got a sequence that is either arithmetic or geometric. We've got a sequence where it's periodic. And what's happening is 2/3 and 3/2 are alternating. Okay, so if we've got to sum this sequence from r equals 1 up to 100, what's going to happen is we're going to have 2/3 add 3/2 add 2/3 add 3/2, etc., 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 all the way down the line until we get to the end. And because we're going to 100, we're going to have 50 lots of 2/3, and we're going to end up with 50 lots of 3/2 because they're just like alternating. So what we need to do is work out what that is going to be. Okay, so that is going to be 100/3 plus 150/2. And we'll add those two together. And when we add them together, that comes to 325/3. And we could just leave it as an improper fraction. If we wanted to write it as a mixed number, we could write it as 108⅓. But either of those would be acceptable. Okay, hope that you found that helpful, and I will see you in the next video.